tri-mode, also known as, what do they call it? Simultaneous mono stereo mix, is what it used to be called. Okay, so basic impedance. If you ever open up like an old, like right there, that house speaker. You open that fucker up, and all it is the tweeter has a cap on the positive side, and then that's it. And then the woofer gets full range. So, and what this does is the cap not only lets the tweeter only play high frequencies, like say from probably 6K and up, and then the woofer will roll off probably right around 5K on its own. So it doesn't need anything else. Some people actually prefer this. So if you ever have a component set and you got your little crossover like this, and it's got your in, it's got your in, and then it says like T plus, T negative, and then woofer plus, woofer negative. So what you can do is just run the tweeter, and then the in, which is plus and negative, just run it straight off this tap, straight back to the mid. Try bypassing this. You don't necessarily need this as a low pass. Sometimes they, at this point in audio, they kind of just do it because you expect it. It's like the box stuffing. If you buy a box from JL and it doesn't have stuffing in it, you're like, oh, what am I paying for? And again, I don't want to call you a dumbass, but it's just because you just don't know any better. That's all. It's not a big deal. So, but so this little thing, this is the XO crossover. This divides the tweeter from the mid, or also known as the woofer. In China, they call it a woofer, even though it's the low frequency driver, LF. And then this is sometimes called HF. Let me show you a couple crossovers real quick. So I did a whole video based on LCR, having a LCR meter, and basically how, like, you really don't need them anymore. But learning basic electronics, learning about how capacitors and inductors work in an AC circuit is valuable. It's very good. So here's your basic crossover. So I got these. These are special SPL 2 ohm. Just means the woofer is 2 ohm. It's the crossover filter is based for 2 ohm. You can actually use a 4 ohm, 8 ohm, whatever. And what you notice is that when you double or halve the impedance, it doubles and halves the crossover point. So for the most part, it gets a little weird sometimes on some of the frequencies, but like, so if you use a 4 ohm tweeter and the crossover is made for 8 ohm, it'll be, I forget which way it is. I think it's above, it's an octave lower, I think, on the tweeter. And then on the mid, it's an octave higher. I forget. Anyways, these are for sale if you want them. $20, it's fine. Get rid of them. These are several different, this is a fancy one. They really didn't need all this stuff, but if you're going to pay, I think at the time it was like $600 for a pair of components from, this is the Orion HCCA if you don't recognize this. This is from like 1998. And this is also optimized for 2 ohm in the low pass because the mid was 2 ohm to extract more voltage out of your amplifier. Does it? At that point, it doesn't really matter. But again, it's a marketing gimmick, so you just kind of go with it. Does it hurt anything? No. So it's fine. You can see the markings right there. So to understand how passive components work in an AC circuit, you got to go back to basic electronics. Now, and there are a couple of ways to do it, which is you can actually wire all the stuff in series, which I've seen Bose do in a couple of their setups. I forget, it's the bookshelf speakers with the 2 tweeters on it, and it uses an 8-inch mid. And I know this because I used to do all the repairs for a pinball guy that he loved those speakers, mostly because they're durable and they can take a lot of abuse. And it's funny because I showed him, I said, the only reason why they can take a lot of abuse is because they put a light bulb in there as the tweeter protector. So like on this one, where is it at? These guys right there. So here, oh no, there's a little one. So right there. And then Orion, whoever designed this crossover, also put a little clipping indicator in there, a little LED, which clips. What was it? I think BearVids does a video on that, where you can use a little tiny speaker to detect clipping on an amplifier, things like that. This one, some of these Orion one, or I'm sorry, Soundstream ones used, I liked them because they used light bulbs. Here's one from Illusion Audio that uses a light bulb in the tweeter. Again, I really like light bulbs, but right now they're hard to find, and so I actually use them to charge the capacitors. When I found a stash of them, I ordered like fucking 3,000 of them. But they were super cheap though. They were the price they were supposed to be, which is like 2 cents each. But they're tough to find because they don't really make them anymore. Everybody's gone to LED. And so what you want to do is find surplus of those. You also find these in like, those were the tubes in like Marshall amps, Marshall stacks, you know, for like guitar. And the bulbs would, sometimes they would use a light bulb too. And there's a woofer protector. You just use a more heavy current light bulb, and you know, want something for more power. And then, you know, the guys would get their rocks off when they play it really distorted, and they, man, check it out, it's lighting up. Ooh, that's how hard I'm rocking. And it's just dumb. It's there to protect the thing, and then they think it's invincible. So here's what I wanted to show you too. These are left over from the Orion ADS auction. These are from the Cobalt 3-way 6x9, and these were handmade. I think they were actually made by Tecate in where is it? It's not, maybe is it Tijuana? I forget. Tecate was a manufacturing plastics facility. They did a lot of ABS injection, and they did a lot of speaker work, but I think they were assembled there in Mexico. And these are labeled HF for high frequency, and then LF for low frequency. There's LF. Focus. So again, and if you cut this open, it's just this, I can feel it right now. There's a simple inductor, which if there's only just one, that's a 6 dB, or a, what is it called? First order crossover. And then there's a cap right there, which is the first order high pass. And so, and then you can also run this where, I've seen them where the woofer just passes through the circuit board, but they want to make it seem like it does something. So they give you a device like this when really it just is a through pass. And then the cap and the coil are used to make a 12 dB or second order high pass. So, but I love this shit. I just love experimenting and having it available, but it's all for sale. If you want to buy it, it's fine. So here's some other crossovers. So here's a fancy one from Concept with big old coils in it. It's probably designed by Larry Frederick. It's got some resistors in there, some really cool components. I think this is right when he they gathered the Concept group and stole them away from ADST, which is ADS, which is Orion. So these always have a weird, there we go. This one is very simple. What's great about this design too, this modular design, they use this circuit board for many, many, many different versions of it, having different slopes depending on the model number. See, this is the 236IM, which is like the basic one. And then they had the 336IM, and then they are an IS and all that kind of stuff. Back to 3-way. So 3-way. Now remember, we talked about at your breaker panel, power comes in. It's 220 volts basically. It's 220, 240 volts. Right? Volts AC. It comes in, and there's 2 wires, right? And so this is 220 volts. Or 240 volts, whatever, same thing. And then there's a ground, right? This goes, then here's the box. And then this goes to ground. If I remember right, that's the symbol for ground. So this is 120 AC, and then there's which is also called L1 or leg 1, and then there's L2, whatever, left, right, doesn't matter. So L2, and this is also 120 volts AC, but it's out of phase with this phase. So technically it's two phase, right? One phase, two phase, but they often call it single phase. But it's actually two phases, and this is exactly how your typical two-channel basic amplifier, which I was talking about, that dual amp, which I love, that's what it does. So on the outputs, you'll notice, let me grab one real quick, hang on. So when I, where's the fucking, there it is. So when I signed up for the Air Force, I knew that I was smarter than the average turd, but it took me a minute to realize that I already knew a lot of the information. I just only knew it how it applied to car audio. And so when I went through technical school there in Biloxi, which was the basic electronics schooling and also teaching troubleshooting and some other stuff, and that school doesn't have to change forever, because those are very basic principles to teach you about different circuits. You can get into other realms, like, you know, fiber or digital or something like that. Doesn't matter. It still is a circuit. In fact, I remember one time when I still worked, I had an interview with this headhunter, and the headhunter got the question wrong. The headhunter was asking the wrong question, and I answered it correctly, and then I just got frustrated with him and turned the job down. I was like, that's okay. I don't want to deal with stupid people, especially somebody that's in charge of me. So, and then luckily the opportunity for ADS-T came along, and I did that, and I've been selling on eBay or whatever online ever since. Anyways, so here is the output, speaker output, and I'll just go with the markings that are on there. You can see them. So it's a negative, then a positive. And again, when I was doing this was in the 90s, and we would look at like a PPI amp or a Rockford amp or whatever it was, and this is actually like a Punch 45. That's what this is. In fact, this is more powerful than a Punch 45. And it's got even better stuff. It's got it's full range. It's got built-in crossovers and bass boost and high level input. That's why I love this fucking amp. So let's go back here. So, all right, so we got your channels, right? So here's channel 1, channel 2, or A and B, whatever you want to call it. So when you take the first, right, and the last, that's bridged, right? And it even says on there, bridge. See it? Right there. Bridge. Okay, so this is 120 volt. And this is 120 volt out of phase, 180 degrees. Okay? So when you tap here and here, you get double the voltage. Okay, so this is going to be what? 150 watts. This is 150 watts. And then when you bridge it, you get 300 watts. But you also have to observe impedance. So each channel is 2 ohm stable, right? So it's 2 ohm, 2 ohm. And then when you bridge it, that's the same thing as 2 ohm, 2 ohm. Each channel is going to see, quote unquote, see 2 ohm here and 2 ohm there. It's basically the same voltage drop, the same voltage draw. Okay, does that make sense? And that's based on a DCR, a direct current resistance. This is not direct current. This is AC. So it's, anyways, we'll talk more about that. Anyways, so that's the idea. That's what bridging is. So this one has 220 volts, just like your wall panel right there. There's 220, but it also has 110 here, 110 here. And usually what they do is on a circuit panel is they'll run this side, this leg, this half of the circuit breaker box to one half of the house, and the other half to the other half of the house, because you don't want any problems where you're touching the stove and the fridge and one is on each leg and you shock yourself, okay? Because the reason why they do that is because in the past they've had them wired like that and people have shocked themselves. Like some ladies sitting there working on a fucking washing machine, and we're talking about one with a wringer that you have to wring out your clothes manually, and she would get shocked. Okay, there's all kinds of stories about that kind of stuff. And usually it's told by not high school teachers, but anybody teaching you electronics about that. But that's the reason why. So, so back to tri-mode. So theoretically, well, it's not theoretically, it's real, is you can run a subwoofer off here. Now, in the old days, we didn't have built-in crossovers, passive crossovers, where they have them on a chip now, a tiny little chip of just a couple of resistors. And so they just didn't include them at all. And so each amp ran full 20 to 20. 20 hertz, oops, sorry, to 20 kilohertz. Again, short note, guys cannot hear this loud, or this high. They only listen to about 16K. This is women, because they have smaller eardrums, smaller tympanic membranes. Everybody can feel this. You can't hear this, you feel this, okay? Just so you know. But this is called full spectrum, also known as white noise, 20 to 20. Or no, sorry, pink noise. White noise is, I think, up to 100K? I forget. This is also called pink noise. Anyways, let me show you this. So you got your two channels from the amp. Let's see. There you go. So we're bridged. Oh, the other thing is, inside, these are ground. These two center ones are touching. And you can see this when you open up like an old PPI amp. You're like, why are they touching? Because they're both the same common. It's the common, it's the ground that both of these voltages are referenced to. This is the ground right here. Boop, 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 boop. Whatever, it's like that. There you go. That's the common. So now, is this common the same as chassis? Well, according to Tony DeMore, it is, but it's not. Because I remember on the old Rockford amps, it would say, do not ground any wire. But in the old days, like Jim Fosgate making a 100-watt booster days, they would use the chassis as a common. The chassis here on the frame of the amplifier and the chassis on the car. You can see that in old Radio Shack boosters and what is it called? What was it? Optimus? Yeah. Well, that's a Radio Shack booster, but Kraco and all those brand names and things like that. It was just a little small. It was a small amplifier is what it was. And they used common ground chassis. Those were typically very noisy, which is why they're not used that anymore. Anyways, tri-mode. So here's your channels, 1 and 2. And typically you can bridge. It looks like this. You put a little inductor in there. And then here's your woofer. Let's see, how do we do this? I haven't done this in a long time. So, and then here's the negative. Zoop, zoop. Zoop, zoop, zoop. So there you go. So this is positive and this is negative. There's your woofer diagram, and this is a 4-ohm driver, and that's how you do it. So basically what you do is on tri-mode, you can run, how do I do this? Let's see, we'll go like that. And we'll that means it's not touching when you do the little hump there. So this is in the trunk, and then this is going to go to the first mid in the rear, which is, oops, well, fuck. God damn it, because that's negative. That's fine. We'll wire them out of phase. It's fine. It works. Which some people actually recommend wiring it out of phase reference to that. So, but here's this mid. Now, here's what you're going to do. You're actually going to put, does that work? There we go. At least one capacitor, typically a 100 microfarad capacitor, which is also known as a base blocker. And what that does is it sends it up from 200 hertz. And then typically the inductor that you want on here is about at 200 hertz as well. And so this is a very simple tri-mode crossover. And you repeat the same thing on the other side. You can actually wire front and rear. We'll go up to the negative, and then again we'll do this positive, even though it's not positive. So you can run left. This is left. These two in parallel to get a 2-ohm load. And then you got the woofer, which is also 4 ohms. And so this is the mistake that Andrew made the other day. He doesn't understand this. So back to the original, let's do a simple, this is a simple 3-way that you see in home audio. This cap will be like a 2 microfarad. This cap will be like a 20 microfarad. And then there'll either be a small inductor or no inductor on the woofer. We'll say, I don't memorize the millihenries. I forget what it's called, but it's basically just it's a coil. Anyway, it's an inductor. that's it. Now this is 8, 8, and 8. These are 8, right? And then you go, well, Patrick, 3 8s in a row, that's 2.6 ohms. I've memorized that. 3 8 ohm loads in parallel is 2.6 ohms. You can't tell me any different. That is true if these 3 drivers are playing the same frequency. So in a subwoofer, where you have 3 subwoofers, right? And we'll say each one of these is D4. So, and you wire each pair of coils in series. So that gives you 8, 8, 8. And then you wire all 3 of those in parallel, 2.6. You betcha. That is true. Because these are playing the same frequency, which is going to be about 20 hertz to, I don't know, I like to be a little high, 150 hertz. And the way that you would cut this off is you would use a small inductor, so you keep the vocals out of there. Real easy. And you calculate for that DCR on the inductor. Now, when you use inductors, it is kind of fuzzy, so it is a little bit of a guessing game. You just don't want to have a lot of overlap. Now, what I mean by that is, let's see. Let's do the old low pass. So we'll say 0 dB. Looks like this. Typically like that. So, and then this is 20. This is 20K. And this is what it typically looks like, where this is like 1, maybe 2 octaves. This is the low pass. And then this is the high pass, which if you look back here, this is typically a coaxial as well, which has a little tiny tweeter on it. And then what do you know? A little tiny capacitor. Now those 2 are wired in parallel. Why isn't it seeing 2 ohm? Because the tweeter is 4 ohm and the mid is 4 ohm, but they just say it's 4 ohm. Why isn't it 2 ohm? That's because these speakers are playing different pass bands. So the band that it passes is, for the low pass, is, let's do the 3 dB drop at like 150 hertz. So right there, that's your 3 dB. This is 150. Okay. So, and then this is it's bridged, so it's half of that. So this is, the amp sees that as 2 ohm, and then because you're wiring these 2 in parallel, it's also 2 ohm. So they can be on the same circuit, right, the same channel, and not play the same frequencies. And when you do that, you do not calculate impedance like this, because they're playing different frequencies. So this is going to stay 8 ohm from like 6K and up. And then this mid has a roll off of about 5K. And so this is going to get crossed up at about 400 hertz. So that's probably bigger, like that. Yeah, probably 200 microfarad. Not typically, but like in my design, sure, whatever. And then this plays from 400 hertz and down. And if it doesn't have an inductor, that means it can play higher than that, but you don't want it to. And that's why you would add an inductor, okay? To keep this from playing vocals. Also to keep from having overlap. So back to here, where if you cross it over, like let's say you cross over the high pass more into here, like that, a little low, in this area right here, you're gonna have a little drop in impedance. It's going to draw a little more current. Now, typically mids and tweeters, you don't really have that problem because their impedance peak, you know, looks like that, and then their lowest is right here. This is this is what you would measure as the impedance, is the lowest resistance. Most of their frequency band or their pass band is way up in here. It's never even here because you're crossing it up, remember, 1 octave above that. So it's typically it's all up here. It's not even as low as it says it is. Does that make sense? I don't know. This is when I review it in my head, I'm like, this sounds way more complicated than, you know, what I started out doing. But basically that's what this is. So you can run simultaneous mono. Mono means 1. And this is a summed signal, so it's getting left and right signals, right? And so that's mono. This is the same way they also derive well, it's one of the ways for a center channel, which you do not need because you only have 2 ears. And so this is left channel. This is tweeter, mid, Those are in parallel, 2 ohm. It's seeing half the bridge load, that's 2 ohm. And so across the 20 to 20, it sees no less than 2 ohm, no lower than 2 ohm. And so this amplifier is fine. It's happy. It runs a little hot, but you can put a fan on it. It's fine, as long as you don't live in Arizona. So, and then you just repeat that for the other side, for your right side. So with this amplifier, you can run down to a 4 ohm load. This can be multiple woofers too, by the way. So in fact, Rockford, back in the old days, a lot of their amps were like 1.5 ohm stable. And so being at about 1.3 is pretty close. And you can run it because, again, back to your impedance, Pete, the lowest impedance is only at like 1 frequency. So as long as the woofer is outside of that, it won't spend a lot of time doing it. It can still play it, but it, again, at that moment, it'll get hot. So if you're focused on that low impedance, that low DCR mark, or it's not DCR, but it's lowest impedance, yeah, you're going to heat up your amp and it's going to, cook and all that kind of shit. So I hope this explains it. So in the problem that we saw with Andrew the other day was we had, let's see, we had Tan Man's. We had made him 4 little enclosures. And inside each one, I had put 2 high-pass filters. I had put I think it was a 2.2. And then this was it was 2 in series. It was 2 100, so it was 200 microfarad. See? That's what I do. I do this. And so the idea is that these only play from, because this was a PA mid, so it only plays from about 300, 400 hertz and up. And then the tweeter only plays like, I think it was like 8K, 6K, something like that. It gets weird in that high frequency because a small change can be like a whole octave sometimes. But so I had planned to use this on channels 3 and 4, and then the inside speakers on channels 1 and 2, and then that way he could control the volume of these pods by using the fader forward and back. So if you wanted the pods louder, like he was going to put them on the back of his truck, he could fade all the way to the rear and it would just be those. And that way, if you got like a soda out of the truck, it wouldn't be like screaming inside the truck. So it would also be nicer to the amplifier. So, but these were meant for, left, and then this is right. And so, and then these are all 4 ohm. So you'd only see 2 ohm per channel. Well, Andrew got confused. He didn't know. And so he's like, well, Patrick, you're running, all these, I think he ran all these tweeters series parallel to get 4 ohm and then put them on 1 channel and then ran all these together series. He added a terminal. He did all kinds of dumb shit. I was like, what the fuck are you doing? Like, again, he could have asked me. He didn't. And I always open myself up to installers. If any installer doesn't understand something that I'm doing untraditionally, call me, talk to me. It's fine. I will explain it. I love showing people different ways to skin a cat. So, and then he did these series parallel for 4 ohm. And then he ran these off 2 channels, which was dumb. He made left channel, he made this left channel and this right channel. So you end up losing the stereo capability. And you also, and anyways, it's wrong, it's dumb. So, and I tried to explain it, but he's hard-headed and he's very proud. So, which makes it very difficult for a student, which is one of the reasons why I kind of kicked him out of here, because he wasn't listening. And then he's like, well, I know enough to get people's trust and trick them. And that's what he does now. So, but, oh, by the way, he goes by LOC_63, I think. If you see him or his comments and stuff like that, which, if I remember right, as a registered sex offender, you're not allowed to go online under a pseudonym. You have to use your real name as your username. So just a heads up. But anyways, he put some mysterious message on there, and I was like, I know this guy. This character, this LOC_63, has been stalking me for a while. I didn't know it was him until recently when he made something about Tanner and his name Andrew. So I think that's it. So choose your inductor wisely based on the DCR of the woofer, and the amp will run fine. Like I said, it'll run a little warm, but that's because it's running at 2 ohm. If you run it at 4 ohm per channel, it'll just not run as hot. And remember, every time you drop your impedance, you double your distortion. Think about that. You also chop your, if anybody's worried about damping characteristics, you chop your damping in half as well every time you drop your impedance. What do you know? So maybe you shouldn't use that 8K at 1 ohm. Maybe you can use it at 2 ohm, 3 ohm, 4 ohm, and there's still plenty of voltage and lots of control. Go figure. You're like, no, I paid my good money. I want a maximum volume, maximum bass. So anyways, that's try mode for you. It's basically just understanding that this tweeter is 8 ohm, but only from 6K and up. From 6K and down to 400 hertz, this is 8 ohm. And so what ends up happening is it looks like this. So you get your, let's see, it'll look like, I think, like this. So you'll have an impedance peak like that for the woofer, and then you'll have one way up here for the mid, and then one for the tweeter. Something like that. It'll be 3 impedance peaks. If you, now this is different if you have the crossovers built in. And basically just if you have like a DATS from, what is it called? Parts Express. Do a DATS sweep on an old home speaker like this and see what it comes up as, even with all the crossovers in it. And then start playing around with the passive crossovers and see what it does to the impedance peak and also what it does to the frequency response. So the only thing I can recommend if you really want to get deep into this is look up inductive reactance and capacitive reactance. And that's going to show you how the filters work. So they resonate at a certain frequency as long as that impedance is a certain impedance. And then outside of that, it's like it destroys it. So anything below, I think if you go about 6 dB per octave, so anything below like 3K is going to be diminished greatly by this tweeter. This tweeter is not going to play below 3K. And it would require lots and lots of voltage to overcome that if this 2 microfarad capacitor was in series with that, was filtering out all that bass. And that's why they call the 100 microfarad caps bass blockers, because that's what it does. It blocks the bass. See, right there. Blocks the bass. And if you put 2 in series, that gives you 200 microfarad. And depending on your impedance, right, like in the case of like we did with these, this was a 4 ohm impedance. And when you put 2 in series, that gives you 200 microfarad, and that gives you a 6 dB slope of right around 400 hertz at 4 ohms. That's how that works. So, and if you wire capacitors in parallel, they double. So, but anyways, we'll get into that another time. Watch my LCR video. I'll put a link to it in the description. I hope this explains why I love this amplifier. Again, I'll show you. Very simple controls. High level, low level. It's got the gain. It's got the crossover. It's got the, what is that? Is that crossover? There's the crossover. The variable crossover. And then it has, it has a bass boost switch. 6 dB or 12 dB. That's fine. I'd rather have a variable, but it works. And as far as bass boost goes, there's nothing wrong with bass boost. I don't know why people got in this weird thing about not using bass boost on the amp. It's just a 1-band equalizer. It's virtually harmless. Well, I don't want to use it because I don't want clipping. Then don't turn it up so loud while using the bass boost. That's all. Weirdo. So, and as far as the rules for what's great is you can run this try mode and still use the bass boost or not use the bass boost. Now, as far as bass boost goes, I don't use any more than plus 12, and I only use plus 12 when working with a sealed box, and that's because the response is real shallow and it needs a little oomph. And it's great that it's built into the amp because most EQs that are built into your head unit are based on small speakers, and so the bass boost on those will be usually about 60-65 hertz. So for a small speaker, it makes it sound like there's bass, but it's actually not bass. But it makes it sound like there's bass. This is the real bass. And I'd love to see somebody run this through the sweeps and find out what the boost is on it, what the Q is, how accurate the crossover is, and all that kind of stuff. Because what's great about this amp is it's all off the shelf. Dual didn't do anything. They didn't design anything. They just said, hey, do you have this? And some Chinese engineering student 30 fucking years ago came up with everything, and they just stick it in there. It's fucking great. And they've been making the same amplifier for like 100 brands for almost 100 years. That's why I like it. It's very affordable. It's reliable. It's great. It does its job. It doesn't complain, and it won't break the bank, and it performs just as good as anything else out there on the market. So, hope you enjoyed this. I love you guys. Merry Christmas and Happy New Year.